friends, welcome back to Science Technology. I am Pavan. So today it's been officially been 11 videos in this Arduino playlist. But this time the video is gonna be on ESP32. So today's video is gonna be a bit different and special. In today's video, I am first going to show you how our today's project is going to work and its functions, and then start building our project. Before that, if you are from India, I would like to give you a very happy Independence Day. Alright, now that we are done with that, let's start our project. Here's my home automation system connected with AC wires into the switchboard. I am currently controlling two relay boards connected to two switches. Now to test it, I am gonna connect it to a power bank. As the lights is on, it's switched on. Now to control it, paste the URL which you will get as an IP address from the ESP32 board after uploading the program, and click enter. As you can see, a board is opened with a website with 4 switches. Any button I click, there is a appliance switched on. Currently, as I said, I have connected two appliances, device 2 and device 3. So when I click my device 3 on, my relay device 3 is on, which makes the balcony light switch on. Then if I switch on my device 2, the device 2 is on, which gets the tube on. Now let's take a look at the code. First, as usual, we have included two libraries. This time the libraries have to be installed, named Wi-Fi.h and Wire.h. The Wi-Fi.h library is for the web browser of the ESP32. You know, from many places you would already know that we can create web browsers and web servers using ESP32, which can control the board. And this Wire.h is to support the library. Then we have given a constant character variable named SSID, and in a string here you will have to give the username, which is the SSID of your router at home. It has to be perfectly right, else it won't work. I have just cancelled mine. You just put yours. Later while uploading, I'll add mine and upload. Then the same thing for password, and the password has to be typed here. For example, SST, and the password is 1234, something like that. Then for the web server, I have given the number 80. The web server port number has set to be 80. Then we have a variable to store the HTTP request. This variable is used to store the HTTP request sent by the ESP32 in the browser. Then few variables to store the current output state of the board, such as off, device 1 state is off, device 2 state is also off, 3 and 4, which can be used later. Then constant integer variables named device 1, device 2, device 3 and device 4. Here you will be able to control 4 devices connected to different GPIO pins on the ESP32. I have just given pin 2, pin 4, pin 15 and pin 16 on the ESP32. Then current time. Unsigned long current time variable with millis function. It measures the current time and gives it in this variable current time. Then the previous time is measured as unsigned long variable with the variable previous time as 0. Then the timeout time in milliseconds, such as the constant long timeout time is 2000. 2000, you already know that it measures in milliseconds, so it just means 2 seconds. Time for void setup. Here first we have begin the serial monitor and given the baud rate as 115200. Then the outputs have been initialized. Device 1 is also output, device 2 output, device 3 output and device 4 output. It's just like ESP32's previous videos and the Arduino videos as well. Pin mode and the pin number and output. This variable has been given here. The pin number has been specified here. Then set outputs to low. The outputs will be set to low. It's quite strange, but in ESP32, when you give the command high, the pin goes low or the LED goes low, and when you give low, it goes high. I was actually confused as well, but it works like this. Unlike Arduino, high means the LED is on and low means LED is off. So it has to be low here and I have given it high. Then connect to Wi-Fi network with SSID and password. This set of code is for the web server creation of the ESP32. Then so serial.print connecting to just for communications, and then in the serial monitor the SSID which you have entered over here will be printed. Then comes Wi-Fi.begin SSID and password. It will take in the SSID and password and check. While means like loop function. It gets repeated until it's connected. Check if the Wi-Fi status is connected, and if yes or if not, delay 500, which is 500 milliseconds, and serial.print dot, which is nothing. Then it's gonna print an IP address generated by the board, which is referred to as the IP address of the ESP32 right here. Then the loop function. In the loop function, first we have given a variable as Wi-Fi client which is equal to server.available. This is from the library. If the new client connects, it prints a message out in a serial port for communication and makes a string to hold incoming data from the client. String right here. In the current time millis which I have given there, and the previous time as current time. So previous time is equal to current time. Then while client.connected and current time minus previous time is less or equal to timeout time or loop while the client is connected. Simpler. Then current time will be equal to millis. If the client available, if there's bytes to read from the client, which means if you are getting data from the client, read the byte and then print it out in the serial monitor. So character C equal to client.read. The data sent from the client, which is the web server, is read by the board and kept it as a variable C, and the serial will print or write C, which is the client data. Then the header plus equal to C. It's just a data type. Then if C is equal to 0, which is if the byte is a new line character, if the current line is blank, you got 2 new line characters in a row. That's the end of the client HTTP request, so send a response. Then if the current line dot length is equal to 0, the HTTP readers always start with a response code. Anything like this, HTTP.1.1. Take this 1.1 has a URL 200 and OK. As you know, there are slashes and many subbars in the URLs of a web browser, a website. It's just like that. And a content type, so the client knows what's coming. Then the blank line. So the content will print whatever is coming as the read function, that is C, and then the client will print some HTML codes which is from the browser and then convert it into commands. Then here's our functions. Turns the relays on and off, which is the LEDs or the bulbs or tube lights which have connected to the relay. Right. So first, if the header dot index of header we are given here, this variable is to store the HTTP request. If the header dot index of, which is the receiving header is off, if it is get/1/on, which is greater or equal to 0, the serial will print as device 1 on and a device 1 state will be on. Here we had given it as off, here it will change to on. And then if it is as off, then for the device 2, device 3, and it goes on. Then for the web server, we need a website where we can get buttons to control. So display the HTML web page. Here we are given a HTML program to display the web page. You can get it in the description. The entire code will be sent in the description. If you want, check it out. I won't waste some more time explaining the HTML code. You just copy and paste it. If you know HTML better, please recommend few more functions which I can add to improve this HTML code. As I don't know much about HTML, please help me out. So I've done a little bit of work which has taught me till here and done. Right. I'd even added some JavaScripts to convert it into a web page and open it up. Then the client will stop the connection and the serial will print client disconnected and leave a line. That's it about the code. Let's upload it. First. Give your SSID and password, and don't forget to change the board and port, and then upload it. So for the corrections, some of you won't know how to connect a relay module to a bulb, so I'll just explain that part. I'm just going to explain one single module of the relay. I used the 4-channel relay. This is a 1-channel relay, which means only one appliance can be connected. I'll just explain this, which will make it easier for 4-channel relay. So in this 1-channel relay, you will have 3 pins over here, one with positive, negative, and one data pin, and here as well 3 pins. Here only these 2 pins will be used. So the first pin will go to the one wire of the bulb, which can be fixed inside the switchboard, and the other the power output, which is as well inside the switchboard, which means when you open up a switchboard, the switch will have 2 pins connected with wires. So one pin will go to this and the other to this. The other wire will be connected to the switch inside the wall. It cannot be shown in the switchboard, so you don't have to worry that you'll get confused. So just connect one wire and the other just like this. This will help you to control it, and these 3 pins to the pins respectively. So now connect the positive pin of the relay module to the Win pin, that is the 9-volt pin in Arduino, but the 5-volt pin or any higher in the ESP32, and the ground pin to the ground of ESP32, and the data pin, which is this is only 1-channel relay, so only one appliance. So the first, as I said in the code, connect that data pin to device state whichever you want. I'll take this as device state 1, so it will be connected to pin 2. So that's all you have to do. Now after this connection, stick it to the wall and secure it. Beware, and precautions are the most important. You see, you are working with an AC appliance, which means it has more than 700 volts of power running. So remember to have precautions, such as before opening up the switchboard, switch off the main power system of your house, which will stop the electricity, and wear rubber gloves just in case. And if you want, you can even wear goggles, which will make it even more safe. If you are below 12 years, please do it in front of an adult or with his guidance, else it may be dangerous. Right, now upload the code and power it up. You will be ready with your home automation system. So friends, that was all for today. I hope you enjoyed the video. Please like, share and subscribe our channel if you find our videos informative. Thank you. Have a nice day.